here is my Mario in the pixel art. Looks pretty good. But hey, what is this? Is it only me, or is it that the Mario is standing behind some kind of a lens? How about this? Wow. Or say, or this. What is going on here? Well, there is no magic here. All that's going on is that we are drawing the same Mario but with unequal pixel sizes. And what that causes is that it distorts the Mario image in a way it looks like Mario is standing behind some kind of a lens. Let's see how we do it. We have covered previously how to draw arbitrary patterns like a Mario. I'm linking that video over here. The idea is that we go row by row. So for example, KK in range n rows. And for every row, we define a color list. Now, color list is an indication, is a instruction to the computer to draw a certain color. For example, 1 means white. So what happens is that on this row, the color list is, for example, all ones. And hence, when I come to the drawing row by row, I just look at the color list for every row. In this case, everything is 1, and hence I draw white. So basically, the color list is telling me what gets drawn in every row. So for example, for row number 2, which is say third row, I have got some reds in between and so on and so forth. So this is how it gets drawn. Now, in fact, we will use the same logic, except that we'll change one important thing, which is that notice here, I'm drawing everything with a fixed pixel size. In this case, 15, but you can also use some other size. What we will do instead is that we will make this change with the row and column index, just like we have done in the two-dimensional grid. So what we are going to do is to define lists to contain heights and the widths that we want for different pixels, and then use them inside this code. Let's see how we do it. So here's the code to draw the basic Mario. I have defined all the color lists, and on every row, I am going by the color list and drawing the rectangles. Now notice here, all the rectangles are drawn 20 by 20, and hence we get a regular, like a pattern with all equal sizes. But as I told you, I am going to now change this. So what I will do is that I will create two lists here. In fact, I've already created two lists. One list called the widths, one list called the heights. And now I'm going to use this within the code. But notice here that the drawing code gets written over several lines. So it's going to be a little bit hard for me to keep changing everything here. What I will do is that I'll define two variables. I'll define these variables as pixel width, and I'll just call it say widths, JJ, because remember width is along the row, and pixel height, I'll call it, let's say, heights KK. Now exactly what we have done in the two-dimensional grid, except that now instead of calling it 2020, what I will do is that I will call here PW, and remember for the height, I want to give a negative number, so I'll make it minus PH. In fact, I'll do the same thing for all the rows. So I just go and make it minus PH. Now, in fact, I've done this for all the rows here. And also remember, my PW controls the width of the pixel, which means I'll no longer change X by just 20, but in fact, I'll change X by PW, and I will change Y value by PH. And this is really all I need to do, because my lists have already been defined. Now once I run this code, notice what's going on here. My Mario looks like it's being seen through a lens. Notice that the height first increases, then decreases, the width decreases and then increases. So hence Mario looks like it's been stretched. And why is this happening? Because the lists are defined the way they are. So width first decreases, then increases, heights first increases, then decreases. Now we can always do, for example, heights is equal to say widths, and we are going to get a different pattern. If I did this, notice my Mario looks really small because both the height and the width first decrease and then increase. But on the other hand, let's say I did reverse of this. I did say widths is equal to say heights. Then what's going to happen is we get this, because again here both width and height are increasing and then decreasing. It looks like Mario has occupied the entire stage. You might wonder, how is it that I can change just one of the two? So for example, let's say I want the height to keep increasing and then decreasing, but I want the width to be always 20. Well, very simple. All you need to do here is to just say PW is equal to 20, because that's my original width. And if I run this code, this is what I get. Notice the width is constant, but the height is changing. Now, really a lot of imagination can go into this. Enjoy this process, try to understand the dynamics, play with these lists, and have fun. Okay. Take care. Thank you so much. Bye bye.